Touchable Sound, a prototype of a museum display for marine data designed to be accessible to blind and low vision learners. Museum exhibits often rely on visualizations or graphics to communicate scientific data to the general public. These visual representations render the benefits of these exhibits inaccessible to blind and low vision learners. While both tactile and auditory representations of data can serve as accessible alternatives to visualizations for blind and low vision learners, there is little work exploring how the unique affordances and drawbacks of these modalities affect learning about data in informal learning environments. Our work seeks to further this understanding through the design and evaluation of an accessible and interactive display for learning about ocean data in Gray's Reef National Marine Sanctuary, a marine sanctuary off the coast of Georgia. In the sanctuary, there are 4 kinds of habitats: dense live bottom, sparse live bottom, flat sand, and rippled sand. Our goal is to help learners understand these different habitat types, their distribution across the sanctuary, and how each habitat type contributes to the biodiversity of the sanctuary. We have 3 prototypes of our computer vision-driven display, each with a different modality. One where habitat is represented by both texture and sound. One where habitat data is represented by texture only. And one where habitat data is represented by only sound. Each map is accompanied by a legend, which consists of 4 squares that play an audio description for each habitat type. Each square is accompanied by the sound and/or texture that represents that habitat type.
Dense live bottom. In this habitat, vibrant, colorful reefs buzzing with life blanket the surface of tall, rocky ledges.
By prototyping multiple versions, we investigate how auditory and tactile feedback can be leveraged to support informal learning about scientific data. We are currently conducting semi-structured interviews to understand how well these prototypes support learners in exploring the geography of the ocean floor and reasoning about the distribution of habitat types. In these interviews, interviewees are tasked with finding certain habitats and marking them on a corresponding Lego grid. We also want to explore how an interactive display could support learners in understanding how different habitats support different kinds of marine wildlife. We are evaluating this through an animal matching activity, where learners place animal figurines on the map based on where they think the animals could live. Although our prototype is intended for use by individual interviewees, our hope is to create a larger multimodal prototype that features the entire habitat map and deploy it in an informal learning space. Currently, our prototype can support the detection of multiple hands. In a larger setting, we envision using speakers to spatialize audio so that sets of learners can explore portions of the larger map together without overwhelming other visitors. Based on early feedback from a small set of these semi-structured interviews, we are also exploring directions including customizable sound mappings,
sparse,
along with fabricating easier interfaces for marking regions on the map, and strengthening connections between the activity and the scientific context in which the data was collected. Ultimately, we hope that our process yields a set of design considerations that outline potential trade-offs for using tactile and auditory representations of data in informal learning environments.